Great. And
Yeah.
yeah, thanks. So my name is Mo Faki with VCA Green. I'm a principal, and we're going to be talking about the 2022 Energy Code, which goes into effect January 1st, 2023. And with me is a special guest, Kennedy Warnkin from Cal Solar. She's going to do a little deeper dive into the solar mandates or the solar requirements for mid-rise buildings. And so once we get to that section, she's going to pop in and give you some information, and I'm sure she'll be able to answer some questions as well. And if you do have questions, go ahead and enter them into the box, and we'll answer them as we get to each section. And let's start. So we're going to talk about California, where we're at now, where we're headed in the next 15 to 20 years. We'll talk about mitigating cost increases because I think your clients are going to be very interested in knowing, well, we're going to incur additional costs next year. First costs are going to go up pretty substantially. So how do we mitigate some of those costs? And we'll show you just quick overviews as to where to look to get some not rebates, but ROI back to your projects. And then we'll go into the code updates. And some of you know us, VCA consultants, we have about 43 years of experience in structural and code compliance. Green was started in 2010, and I joined in 2012. When there was two of us, Glenn and I, and we've grown the Green team up to 25 people. And our structural team, they focus on mid-rise buildings, high-rise towers, concrete and wood construction. And our code people, they're working as plan checkers, plans examiners in different cities as outsourced staff. And that's our team. And so we really try to remove compliance hurdles. So this is a pretty cool photo. We get those tripping hazards out of your way to make things a little easier, especially when it comes to Cal Green and energy code. These codes are changing every 3 years. And so we're always having to update our knowledge as to what the new changes are, how are they going to affect your projects, what's the cost going to be. And then the plan checkers and building officials have to train themselves as well. Sometimes they miss things in plan check and they hit you later on down the road in the permitting path. And so they're trying to figure things out as well. And you can see our building officials on the right corner of that photo there, Minister of Funny Walks. So California Senate Bill 100. So this is the clean, 100% clean electricity bill. And so the state wants to go completely 100% renewable by 2045, meaning every ounce of kilowatt hours going through our power lines will come from clean energy sources. That's going to be, solar and wind, but more than likely we'll have to switch over to nuclear power because how are we going to produce during off-peak times, right? So we're going to have, uh, you know, uh, um, additional infrastructure that's going to be built. We're going to have increased demand. We're going to have electric vehicles plugged into the grid. So there's going to be increased stress on the grid. And so more than likely, these mesh networks will be created where they have these decentralized grids where, let's say, a UC campus would have electric power with large battery backup, and they'll store their own, create their own energy, store their own energy. And then when they're producing excess, they're going to dump into the grid. And there'll be maybe another campus up the road, maybe a business park up the road that's also doing the same thing. So basically you have this like mesh network or this like spider web of decentralized producers, mini producers that are helping stabilize the grid. And then of course, we'll be pumping in or piping in clean energy from neighboring states as well. So the state really hasn't said how we're going to do this. It's a goal. And so they're going to figure it out as they move forward. And then LA, of course, has a carbon neutral policy by 2035. So all the energy that's produced in the city of LA, they want to offset all of that, 100% of it, to clean power, clean sources by 2035. And they're going to push some efficiencies on the demand side, which means our buildings. And that's what we're going to talk about today. And the benchmarking law for existing buildings is in effect. What we're going to be talking about today is new construction, but the energy benchmarking law, AB 802, is in place right now, and this is for all buildings basically that are over 50,000 square feet. Your multifamily units or buildings with 16 or more units all have to measure their Energy Star score through Portfolio Manager and report that every year. So that one's interesting. You don't have to be at a certain score, you just have to report it. And buildings that are inefficient are going to get resources or information to improve the efficiencies of those buildings. Let me make sure I can see chat right now. Okay. Okay, great. Yeah, I just want to make sure it's there so I don't miss anything. Okay, great. So mitigating costs, some of your owners are going to want to know this one here. And energy modeling is a great way of figuring out what elements you want to put in the building, especially next code cycle. It's this code cycle, we've been able to get a lot of wins through enhanced energy modeling. You want to make sure the envelope's designed properly. You're getting all the shading down, the side fins, the building angle itself. All of that contributes to the efficiency of the building. And then you want to model in your systems. And quite often, if you model the envelope properly and you actually use the right values for your windows and for your wall, the window area, we actually get better performance. And so sometimes you can reduce the efficiency of the systems. Per code, this doesn't really affect solar. Solar is marginally impacted with this kind of approach. So I'll talk about that in a little bit more detail, but there's really big savings here. HVAC system sizing, I'll cover that one in a little bit more detail, but there's big savings. Most HVAC systems are oversized for single family homes, for multifamily homes. Um, a rule of thumb was to use 400 CFMs per, what was it, 400 CFMs per, was it square foot? Yeah, per square foot. And so that ends up adding additional tonnages, to the design. So quite often you can walk that back, and I'll describe that in more detail. HERS design review, there's going to be requirements to test all these new systems in the field, and you want to make sure that your notes, your sections, your insulation notes, your air sealing notes are all in your plan, so that way you cover yourselves going into construction phase, because a lot of general contractors are unfamiliar with HERS, or they kind of gloss over it once testing comes around. There's some trips that happen out in the field, and so we want to avoid that as much as possible. Also, early construction coordination is critical too, that these HERS measures get hit, and I'll cover those as well. Acceptance testing for lighting design. So lighting gets designed often after the project is permitted, right? You'll have some control diagrams, maybe some line diagrams in your electrical drawings, but you won't necessarily have the equipment spec'd until construction. And sometimes the wrong equipment gets spec'd or too much equipment gets spec'd. So an opportunity is to QC that. And then energy assessments and warranty walks for people who are long-term holders. This is really good. We can actually come back 10 months after the building is built, find a bunch of issues and make corrective actions and reduce the operating costs of these buildings. We've actually saved buildings anywhere from, they have 5 to 12,000 up to $20,000 a month in savings. So it's pretty significant. These are just some basic case studies of energy modeling that saves quite a bit of money. The project A, I'll only focus on that right now. The MEP spec'd hydronic heating. So using hot water to heat the residential units. And when we ran our model, we saw they can switch to heat pumps. And why was that? Well, they modeled entire floor plates as one giant space, and the building was oriented in the wrong direction. So that ended up causing the need to add hydronic heating through gas, which was less intense than using grid power. So when we reran the model, we switched to heat pumps and we saved the project $900,000. That's because we just oriented the building correctly and designed all the floor spaces and all the units 100%. So that's just a small example of why energy modeling is important. And then for HVAC sizing, so quick example, you'll have, let's say, certain unit types will receive, let's say, 3 tons. So let's say this 2-bedroom unit on the southwest corner is going to be the hottest unit. It's going to get pummeled by solar radiation. And so the HVAC designer will spec, let's say, 3 tons. Well, that same unit type is going to be replicated on the north side of the building, stacked units that are shaded, never going to get direct sunlight, but they may also have 3 tons as well. So you can actually downsize that 3 ton back down to 2, maybe even 1.5 tons, and save quite a bit of money back to the owner. And most projects have this opportunity to save on every unit pretty much, for the most part. Okay. Third-party ratings are a thing as well. So ESG is becoming more popular now, and let me minimize this. And so ESG is environmental, social, and governance. And so private companies that are publicly held want to get included into these socially responsible funds. And ESG is one of those directives that allows them to show transparency to those stakeholders or those investors. So ESG is a process of reporting what you're doing internally with your business practice from a corporate and social responsibility standpoint. So ESG is driving LEED, it's driving Build It Green, NGBS, Energy Star. We're seeing a lot more requests for LEED now because of ESG. And ESG is one of those or LEED is one of those check boxes for ESG. So you may see that coming down the pike as well. And agencies like San Jose, Mountain View, Oakland, they're going to maintain their ordinances where you're doing Build It Green or you're doing LEED. So those will still be in place. And then probably a program that's probably not as well known as the Fannie Mae Green Mortgage Insurance Premium Program. This one's really good if a project needs additional funding. They can opt into one of these green building ratings and get a 0.25% reduction in their mortgage insurance premium. So if you have an owner or a larger developer who needs additional funding, this could be a source. Okay, so that's kind of an overview leading down to the proposed changes. And so what's coming up? So we'll start with single family first, and then we'll go to multifamily. So for January 1st, 2023, it's only a few months away, they're going to have a third score that we have to track. Before it was just TDV, now it's these energy design ratings that we have to track. And how are they or what are they? So the first one is source EDR. So where is the energy coming from, right? Are you using gas on site or are you going all electric? Well, if you're using gas, you're going to get penalized in the energy model. So you're going to have to make that up with higher efficiency on the electric side because the code is trying to de-incentivize gas use. So they're shifting towards all electric. So source, where is your energy coming from, right? Is it also coming from solar farms? Is that going to impact the energy model? We don't know yet. In fact, a beta of the energy model is just released and it may be buggy. We're not sure. We're diving into it, but we don't know how all of this is going to look like until we actually get in and start modeling. Hopefully by the summer, we'll know. Efficiency EDR is the second one. That's how efficient your building is and what's going on site, your lighting, your mechanical, your plumbing, your envelope. So that will, actually lighting's not regulated, but these other systems are. And so source EDR and efficiency EDR combined gives you your total EDR, and your total EDR has to meet code with solar. So you slap solar on top, and then now you meet the solar EDR. So you have to meet source, you have to meet efficiency on site, and then you have to meet it with all those combined with solar. So solar is going to offset some of that, if that makes sense. So that's how they're going to look at it. Three new metrics or three metrics to follow. And so there's an update, and the update is there's a new multifamily section, and they're going to group low-rise and high-rise into one classification. So right now, the energy code calls 4 stories or more non-res. Everything else 3 stories or less is considered residential. So a high-rise multifamily building, current code cycle is looked at as this in the same light as an office building, all right, or a hotel. So now they're going to say, no, multifamily has its own classification, its own section, and they're going to treat it a little differently. It's still going to be more of a non-res type of thing, but they're making it a little less confusing, right? So single family, which includes townhomes, and then everything else will be considered multifamily. And then non-residential spaces would still be considered classified as non-residential. So your amenities are still considered non-res. Okay. So single family, this is mandatory and this is new. And I have a little tag on here, a little circle that says SF. So as you go through, I put these on here just so you don't, because we're going to switch to multifamily. You'll know what's single family and what's multifamily. But new attic systems have to have insulation above or below the roof deck, or a combination. And you have to meet the 0.18584 U factor. So you're either going to have ceiling insulation, or more than likely you'll have ceiling insulation like a R30 or R36, And then you're going to hang bat on the ceiling, or sorry, the roof, under the roof deck, or you're going to put rigid insulation above the roof deck. So if you can't meet the U factor for the roof / attic with hanging bat, you're going to have to switch to a polystyrene or some kind of rigid foam on the exterior. And this is mandatory. And this U factor is what needs to be hit, 0.184. So you can come up with almost whatever design you can come up with putting as much insulation as you need. But more than likely, rigid will be used. Actually, it's hard to say right now, but rigid will definitely get you there. It really depends on your design and what you have going on as an architect. So you have to probably run that assessment early before you get too far into design. New kitchen hoods are going to be stronger. And so there's going to be two classifications, a hood over the electric range and a hood over the natural gas range. So obviously, if you have natural gas, those things have emissions. And so they want a stronger CFMs through that kitchen hood. That means you're going to have to enlarge the ducting, the exhaust duct, maybe 6 inches or more to get all that air out. It's going to be loud. It's going to, don't have any small pets close to that thing because that thing's going to be powerful. It's going to suck up your cat or something. So just know that you're going to have to spec different hoods depending on whether you're using electric or gas cooking. Okay. Question is it possible to get a copy of the material? Yeah, we can send out copies. Just go ahead and email me, and then we'll get you a copy. And then so cooktops. So now these do not affect your energy model. These are unregulated loads. So these are called process or plug loads. And so, but if you're going zero gas, more than likely you're going to go with an electric cooktop. Induction, you're probably going to do induction in a custom home of some sort, but you're probably not going to use induction in a production build because you have to use special pots, special pans, basically stainless steel or cast iron. I have one of these. And the way induction works is it heats the pan through electromagnetics. So the cook surface does not heat up at all. So you can see that egg sitting there. That cooktop is on. It's heating the pan, but not the surface. So the egg's not getting cooked on the surface, it's getting cooked on the pan. The pan becomes the cooking surface, and it has pretty even heat, kind of similar to gas. Edison and some other utilities are trying to get chefs to use induction to try to get them to buy off on it because chefs love gas. So that's still out for judgment. We're not sure which way that's going to go. I love induction, works well. But for the most part, when you go all electric, you're going to be using those electric burners. Another thing, induction works really well in senior housing or assisted care where people can't hurt themselves. So ventilation duct sizing is going to be mandatory minimum sizes. So if your HVAC team may need space up in the attic or in drop ceilings to get that ducting to the right size, just as an FYI. So they're locking in the mandatory sizing. It's not really going up too much. It's pretty consistent with current code cycle, but they're clarifying the minimum mandatory requirement. And so energy storage, battery ready. So for single family homes, you'll have to be battery ready, kind of like your EV ready. So, and this is prescriptive. Let me back up here real quick. Prescriptive means the code is going to grade your energy model. This is for new construction to the prescriptive standard. Or if you're going to be adding, rooms or doing a large expansion, this may get triggered. We're not sure yet, but definitely for new construction. So instead of having, your EV ready, you're going to have your EV ready like per Cal Green, but now you're going to have battery ready as well, where you're going to be running your conduit. You're going to have space for your panel. You're going to have maybe some circuits put in and get it ready for that future use. Okay. And so if you don't do it, the energy model is going to ping you, and then you're going to have to make that up somewhere else. And the panel has to be a minimum of 225 amps. That's pretty big. So that's going to be plenty of power going into the future. They're probably gonna be able to put a pool and a jacuzzi in that home later on, but that's pretty big. So that's a pretty big bump up. I think 150 is what we've been seeing. 100 is the minimum. So that's a huge jump. And you have to have sufficient space too for your equipment. And still in single family, electric ready for water heaters and furnaces. So if you're putting in gas lines, great, you can put your gas lines in, but you also have to put in your outlets. So you have to put in your 220s, or sorry, 240s, and get that pre-wired. So in case the tenant or the homeowner ends up wanting to put in all electric later on, they can do that. They can cut off their gas and put electric in there. The cooktop, the dryers all have to have pre-wired. They have to be pre-wired. So basically what you're doing is you're pre-wiring for these appliances, and you might just end up saying, you know what, let's just, since we're having to run all this cabling and account for the load, maybe we just go to all electric and just cut out the gas and save money on gas, because more than likely it's going to be cheaper to go all electric given these requirements here. Again, these are prescriptive. You don't have to do it. So you can still put your gas in, but then you have to bump up your efficiencies everywhere else, like your hot water, your windows, your HVAC, etc. But there may be a decision down the road that, yeah, let's just go all electric. It's just easier. That's what the code's trying to do. Okay. Check real here. With insulation, going back to insulation, what happens to flat, low slope roofs? For flat roofs, more than likely, prescriptively, you're going to need rigid insulation for new construction. You don't have to do it, but you'll get dinged in the energy model if you don't do rigid insulation up top. And then you can decide whether you want it vented or unvented. Okay, domestic hot water is allowed prescriptively. That's the heat pump water heater. Let me go back here. Okay, yeah. So heat pump water heaters, solar hot water heating with electric backup and minimum of 70% solar fraction. This basically means that if you don't put in a heat pump water heater, or if you don't put in solar hot water preheat, you're going to get dinged in the energy model. And how a heat pump water heater works is it's a heat transfer device, right? So it's taking, let's say, 70-degree air out of the air and putting it into these coils. So these coils heat up to 70 degrees, let's say. And then you have 60-degree water coming in from the municipality. And then that water washes over the coils, and the heat in the coils gets transferred into the water. So you're taking that 60-degree water and you're preheating it to, let's say, 75 to 77 degrees. And then now you heat that water up to 120 or 140. So you're preheating just using the air. And that's a big energy savers, and we get really good results in the energy model when we use heat pump water heaters. And that's how they work in general. So again, these are all prescriptive measures, right? And then solar photovoltaics, that's not changing. This is current code right now. So for your low-rise projects, you're going to see solar PV continuously moving forward. So that's not changing. Nothing's really changing there. They're keeping it the same. So you can see that development there in this picture. That's a current code development. You can see how much solar is being put on those roofs for single family. Okay. Additions and alterations. So if you're doing a re-roof, even if you're replacing the tile, if your re-roof is triggering a permit, you'll have to go through these steps here. So you're going to need, well, indoor air quality fans, that's for your bath fans. If you change out your bath fans, you're going to have to put in CalGreen compliant fans. And then duct systems, Alterations duct system leakage must now test at 10%, formerly 15%. So if you put in new ducts, you're going to need to test the ducts. Altered ceilings must be insulated. So the ceilings up top on the ceiling deck has to be insulated depending on your climate zone. Okay. And then for re-roofs, I started with this one early. With re-roofs, you're going to need to, prescriptively, you'll be adding insulation depending on your climate zone. So if you do a the roof assembly U factor will be 0.039, meaning if you do a re-roof and you don't really have much insulation up there, you're going to do rigid insulation on the roof deck. So that's going to add some cost. If you can get your ceiling insulation, your attic insulation up, you might be able to avoid that, but more than likely you won't be able to in these climate zones. Okay. And this is for single family, and it also applies to multifamily re-roofing as well. So pretty big change there. Right? And even shingles, technically, if you replace your tile roof, that's going to trigger the code because there's cool roof requirements prescriptively, and you have to meet those cool roof requirements. So that's something to be mindful of. Okay. All right. Okay, multifamily. Let me pause real quick and check out some questions. Okay. How do you approach with a home in the mountains? Oops, sorry. How do you approach a home in the mountains with a snow load of 10 feet and ice that destroys rooftop panels? There are going to be some exceptions. Maybe Kennedy can answer this. I don't know if there's any ways to, the code doesn't talk about snow loads, doesn't say that's an exception. So I'm wondering, how do you protect your solar panels when it's snowing outside? Kennedy, do you know the answer to that one?
I do not know the answer to that, but that's a really great question. Yeah.
It is. It is a really good question. I'm thinking maybe, I wonder if there's heating elements that you can run through there to, to melt the snow potentially. That could be one method. Or if it's a life safety issue, then you can try to get an exception because the energy code allows you to do exceptions if there's a life safety concern. So you'd want to talk to the agency and see if there's an out there on that one. Okay. All right, so we're almost at your slides, Kennedy. So we're in multifamily now. So that was the single family section we just covered. Now we're going to hit multifamily. And so per code, as the architects, you have to identify your solar roof area. So identify where your PV is going to go. And then a company like Cal Solar will come in and say, okay, here's where we can put all our panels, based on what you need per code. And so there are exceptions, right? So any roof area that has less than 70% annual solar access, you're exempt from putting on solar. That means basically a roof that is blocked by other larger buildings or a mountain range, or there's very minimal solar access for whatever physical site conditions are going on site. So they're not going to force you to put solar up there if you can't generate enough solar. So that's a good thing. But look at the exceptions when you're going in and make sure that, see if you can qualify for one of the exceptions before you get too far into design. And photovoltaic budget. So the Energy Commission, CEC, didn't produce tables yet. So I pulled these from Energy Code ACE, which is a great resource. If you ever want to dive a little deeper in the code, Energy Code ACE has some really good resources there. This is one of their tables. For multifamily, they're going to give you a photovoltaic budget based on total conditioned floor area or conditioned floor area in square feet. And there's a formula that's going to be worked out, and then you're going to have to add solar. The solar that you're going to be adding is typically going to be more than what you're adding for single family or for low rise. So it's going to be more solar that you're going to be adding there based on the formula. And then the energy model is going to produce a photovoltaic budget. And I showed you those EDR scores earlier. That's where your photovoltaic budget is going to come in. So basically, you're going to be given, let's say, 40 kilowatt hours per year of solar production. Now it's up to you and to the solar consultant to figure out where you want to put that solar. So again, here are the exceptions. So you can take a look at those. And let's see, the building has an enforcement authority, approved roof design, and the enforcement authority determines it's not possible for a PV system to meet ASCE 7 through 16, Chapter 7, snow loads. Oh yeah, so I thought I had this question answered, but there's the answer to that snow load question. If the agency says, yeah, this is a life safety issue, those things are gonna get smashed because of a snow load, then you're exempt. So there it is, we got that question answered. Battery storage will also be prescriptive. So they're going to grade you when you do your energy model. You're going to get graded on battery storage being in the building. You don't have to put it in. And so there's going to be minimum power capacities to battery storage. You'll have to figure out where to put it. And if you want to put it in, it's what your ROI is going to be. If it's a long-term hold, it may be worthwhile. But yeah, you figure out, if you have the budget too going in to afford these things. And then they're basically, for your typical multifamily home building, maybe 150 units, you may be seeing 2 large refrigerator sized battery units to store battery, to store a solar photovoltaic production. And you're going to store it during the day, and then you're going to release it into the building in the evening hours during your peak times. So maybe Kennedy can speak about ROI on that, but that's kind of an overview of the battery backup and solar. Okay. All right, Kennedy, you want to jump in here?
Yes, thank you, Mo. Thank you all for being here. I'm just going to talk a little bit about design coordination for solar and storage, and some things that you might need to consider earlier on in the design process to avoid some conflicts later on as the project continues on. So you can go ahead and go to the next slide, Mo.
Okay.
So just a little overview of who we are at Cal Solar. We've completed over 500 renewable energy projects throughout California. We do PV, battery storage. We started as a solar thermal contractor, and then we also do EV charging. And we've got a team of over 80 in-house designers, engineers, installers, and local crews that are based throughout the state of California. And we've completed projects in over 13 California utility territories, in over 130 AHJs in different cities throughout California. And our construction team, we pride ourselves on having an in-house construction team. They have 250 years of combined construction management experience in solar alone. So we are very equipped and ready to help throughout the design process, but then also throughout the entire construction process as well. So our engineering and design process that we go through when you're starting a PV project, we want to look at your targets, whether that's to meet code or to meet any green building goals, lead any of those green building programs as well. And then we'll take a look at the scopes that you want to fill. So whether that's PV, battery, EV, or all of them. And then we'll look into the equipment that is rated highly at the time and use the best option that's available. And then we'll take a look at your building and see what kind of switchgear you're using and other equipment that you're currently specifying on the project. And then we'll coordinate with your design team and project team to make sure that we have all the information that we need to engage our estimating and engineering team. And then they will start designing the system. And so once they have designed the system, they will produce a plan set, and they'll do any quality assurance and control that is needed there. And then they will send those plans to a permit or to permitting, and will reply to any plan check comments, and then carry those plans through all the way through the permitting process as well. And then once we get the permit back, we will hand it off to our construction team and then provide any ongoing support from the estimating, engineering, and kind of the solar consultant side as the construction team continues to build the project and as the client has any questions throughout as well. And so our main message here is just that bringing us on as soon as possible really avoids conflicts. There's a ton of coordination that we need to do, and I'll kind of dive deeper into it on the next slide, but that needs to be done during the design phase, and that can really avoid unnecessary costs and delays throughout the process as well. So some of these coordination considerations, we'll coordinate with architects to determine any vents, drains, locations on the roof area, and then also any like EBM attachments that are on the roof that will require some sort of setback from the roof parapet. And then also fire access setbacks, these kind of range depending on the fire code. And these are all for roof area. And then for carports, we need to know where the ADA accessible spots will be in the parking lots for carports, and then also where the fire lanes will be located as well. And then your structural team, we will need to know where the roof blocking is placed. And sometimes we need to coordinate to add additional blocking to support our stanchion systems that we install for our PV panel racking. And then depending on where the project is located and kind of what type of racking system that our estimating and engineering team determine will be the best for the project. That could be a ballast system, which requires 8 pounds per square feet of additional dead load on the roof. So we need to coordinate with your structural team to make sure that that dead load is available on the roof from the beginning of the project. We also coordinate with the mechanical team. We want to make sure that the HVAC equipment to place the condensing units on the north side of the roof area to avoid any panel shading and to optimize production of the PV system. And then also with your plumbing team to coordinate where the water hoses will be placed to clean the PV panels as well. Electrical is super important. We need to know the tie-in points, whether it's a line side, load side, utility side, and then also to determine what kind of metering the building owner would like to use. And then also laying the conduit. So either wiring the conduit from the utility room, the electrical room up to the roof or to the carports in the trenching in the ground. And then also at the end, we want to make sure that our system is waterproofed. So we want to waterproof the stanchions and posts to avoid roof buildup and maintain the warranty as well. So as you can see with all of those things that I just mentioned, historically solar has been a deferred submittal. It's the last thing to go up, it's the roof. So it's not often thought about, but these things are really determined early on in the project. And so it's really important that you bring us on early so that we can engage with all of these different trades to make sure that it's a smooth and cost-effective project as well.
We're actually starting with solar first in this presentation. We're actually starting at the top and going down.
Yes, it should be that way.
It's kind of reverse thinking from how it's typically done.
Totally, yes. So here's a few examples, and I kind of briefly mentioned a few of these on the previous slides, but we look at the fire code. So the setbacks that are required for the fire code are a 4-foot setback from the roof edges, a 4-foot wide access pathway between any roof obstructions or away from any roof obstructions, and then also a 3 to 4 foot deep working clearance in front of equipment with a 6.5 foot minimum headroom. We also take a look at OSHA. So these typical setbacks are 4 to 6 feet from the roof parapets as well, and they may be more if that roof parapet height is lower. And then again, with your EBM trades, especially on high-rise, mid-rise projects, we want to make sure that any sort of EBM, like a davit, there's plenty of room on the roof to have those without any panels getting in the way. So these kind of require a range of clearance as well, usually between 4 and 8 feet. And they really depend on the chosen suspended access system. Some more examples. So I mentioned this one before as well, the blocking for the stanchions. The framer may need to lay additional blocking to support those stanchion bases that support the PV racking. And then also the electrical tie-in. If this isn't coordinated early on in the project, it could require a brand new switchgear, a different type of switchgear to be purchased, which can get extremely costly and overrun the budget totally. And then a little bit into battery storage. So there are some things to consider, especially because batteries are included in this upcoming code update. We typically recommend that batteries are placed outside due to just fire code, and it's easier to have like air moving through the battery and make sure that they're ventilated properly. But if you do place them inside, fire code does require sprinklers, ventilation, and a few other things for indoor placement. We also like you to know that battery footprints are dynamic. The battery industry is changing really quickly. Battery sizing is changing very quickly, and therefore battery dimensions are changing really quickly. So the space that you set aside to place a battery today may not fit a battery in 5 to 10 years, or it's just something to consider that's really important. And then this image over to the right is actually a company that we work with at Cal Solar called Yada. And they're a really interesting battery solution where the battery is actually placed in a ballasted racking system. So it's a 50-pound battery that's actually sits underneath each individual solar panel. And so you can have 1 kilowatt hour of a battery storage underneath a panel. So it kind of minimizes a lot of those spatial problems and considerations that we run into with larger batteries. And then for the battery storage ready, it does require a dedicated emergency panel with breakers. So if this is overlooked, you have to completely redo any wiring. And it's also important to really plan for the battery space with the battery storage ready code. Unless you're planning on using YADA down the line, but you want to make sure that you have enough space to place the battery as well. And then also something to consider is that batteries right now have really long lead times. So if you know that your project is going to use a battery, or your client wants to install a battery, you want to put the deposit down on the battery as soon as possible. It mitigates the need to change the batteries later on in the project and redo a large portion of the design process as well.
Do you see the battery technology shifting mid-design or from design to construction and having to make some changes later?
We have had a few projects where just because battery manufacturers right now are just kind of all over the place, we've like not gone through with a few battery installations because from the beginning of the design phase into the construction, that battery manufacturer has faulted or their product has tested badly. So it's kind of a tough a tough game right now.
Yeah, definitely the industry is adapting. And so the early adopters are going to learn a few lessons, I think. And as soon as you get your 8-track tape player, you're gonna have to put in your cassette player. As soon as you put in your cassette player, you're gonna have to put in your CD.
Totally.
And then
Yes.
yeah, great.
Yes.
That was really good. Thank you, Kennedy.
Thank you so much.
Of course. Let me see if there was any questions. Kind of okay. No, yep, no chats, no questions. Okay, so that was good. So yeah, that was the solar overview. And then from an electric standpoint for multifamily, we're going to have to be at electric ready as a mandatory requirement. So this is not prescriptive like it is in single family. In multifamily, you actually have to add your Romex, your amperage, your feeds all through the building, including residential units. So this means every single unit is going to be electric ready, and that's going to add significant cost if you consider adding gas at the same time. So basically, you're going to be adding 2 components, and you may just want to eliminate gas. And so that's the intent here. That's where the code is headed. The Westinghouse home from 1959, really cool YouTube video. If you ever want to check that out, that's an all electric building, and they have some pretty neat little features there that are pretty retro and things we're starting to apply today. It's a pretty interesting view. So that's your mandatory all electric ready requirement. Now for envelope, there are some changes with the envelope on multifamily and roof, wall, and floor insulation. We're going to talk about that. QII, there's some changes, some learning lessons that we've had this code cycle that are going to be applied next code cycle. Windows are going to stay pretty much the same. Exterior doors are going to need to be insulated, and then additions and alterations are going to meet low rise or single family. And I want to show you this climate zone map because we're going to be talking a lot about climate zones. So depending on where your project is, that's going to trigger certain insulation values. Maybe you're going to be exempted from certain types of equipment. And so your solar zone, your climate zone is going to determine really the path you're going to take for energy efficiency or energy code compliance. And so with roof and ceiling insulation for multifamily, this is prescriptive, and this is option B, which is attic below roof deck, right? So your attic would need to be insulated at a minimum R38 or R30, depending on your climate zone. So coming back to our climate zone map, if you look at Orange County, we're at climate zone 8, or we're at climate zone 10. So the 5 freeway splits 8 and 10. So depending where you are, you have a project that can be in one of those 2 climate zones in Orange County. And so here's 8 and 10. So below roof deck insulation with airspace. So your roof deck insulation, you're going to pin R19 bat below your roof deck, right? And then you're going to do R38 ceiling insulation. So you're going to have that high performance attic going on prescriptively. Again, you don't have to do this. You can go down to R30 with no insulation on the roof deck. If you've passed the energy model, if you pass the performance-based model, then you pass code. You don't have to do this. So this is one of those things you want to model in and see if you need to put it in or not, or it may just make sense to put in the insulation if you have the room for it. Cool roofs as well. Cool roofs only apply to climate zones 10 all the way up through 16, kind of like the hotter, more extreme climate zones. If you see here, 10 through 16, these the climate zones get a lot more solar exposure. They get a little hotter than the coastal communities. So those climate zones would require cool roofs. So you're exempted from cool roofs moving forward next code cycle in the more moderate climate zones. So that should help. Ducts and condition space. So there's requirements there. That's option C. If you have that, that gets triggered. If you have ducts in condition space, then the insulation requirements are loosened up. So picture looking up and you see ducts inside the space or in drop soffits. Those are considered conditioned. Any ducts that are in a drop, those are in conditioned space. Where they're talking about really ducts that are in attic, unconditioned attic areas, that would follow option A or option B. Okay. Option D focuses on non-attic roof, right? So you don't have an attic. This is where you're going to put your rigid insulation. The question was asked about that. So you're going to add rigid insulation to your roof deck prescriptively. You don't have to do it, but if you don't, you'll get penalized in the energy model. And then the cool roof gets extended out. So here's the age solar reflectance and the thermal emittance. This is your cool roof right here section. As you can see in the more moderate climate zones, if you just have a flat roof, the cool roof is required. That's your prescriptively required. So that's your TPO type of membrane. Okay. Quality insulation installation. So for that one, oops, let's see. Yeah, for QII, this is current and active this code cycle. It's going to be implemented as well next code cycle. So if QII is triggered as a result of energy modeling, in most cases it is, insulated headers are required. And this was missed in the earlier code 2019 code projects, and we're getting caught up on these now. But there's a little small section in the code that says these need to be insulated. Most people miss that. So if you have QII, heads up, you're going to have insulated headers, which means these are the headers that are facing exterior wall segments, meaning over windows, facing unconditioned space. So it doesn't have to go on the interior units, right? So bedrooms, etc. So these would have to be engineered in the field or pre-cut or prefabricated and put in place. Now, is that going to be better than putting in SEER 16 or increasing the SEER ratings on your HVAC units? Can you increase the efficiency on your HVAC units to avoid this? Potentially you could, depending on the type of building and the climate zone, but you're definitely gonna have to increase the efficiencies of your boiler system, of your HVAC, of your windows, or combination of those three to be able to remove QII. So it's a tough pill to swallow. So if you do see QII in your HERS report, or you have new construction 3 stories or less down to single family, this is going to get triggered. Just a heads up. Windows. So with windows, the U factors are listed here prescriptively. The solar heat gain coefficients are listed here per climate zone. So you want to take a look at where your climate zone is and at least spec out these values, and you can easily achieve these values with what's out in the market. So this isn't really a budget buster. This is one of your easier items. And so the energy modeler wants to see these values for the windows, the window types, and they want to see this in the window schedule as well. Fenestration area, you're actually allowed a maximum amount of fenestration, but people love windows. And if you have a great views, you want more of that. So you're going to design in bigger windows, and then you're going to take a little hit in the energy model, sometimes a bigger hit, to have those views. Then we have to make that up somewhere else. Doors have to be insulated now to R5 prescriptively. This one is really not a huge factor in the energy model. It's a very small surface area. It's just a door. If you have multiple exterior doors in, let's say, a garden project, a 3-story walk-up project, maybe you'll see a little bit of an impact, but really not much. I wouldn't stress about this one, but R5 insulation is required. Certain types of wood, I would assume, may be able to get you there, but those doors need to be insulated. For envelope additions and alterations, you're going to follow the previous section that I just covered. So the attic, the cool roof requirements, the ducting, the bath fan, etc. all of that's going to apply to multifamily. Okay, so that was envelope. Let's go to mechanical. What's new? And so next code cycle, this is a federal requirement. DOE is coming out saying we have to bump up our SEER ratings on all our equipment. This is a pretty big deal. So we're going from SEER 14 to SEER 15 next code cycle. If you are in, here's the Southwest, right? The Southwest climate zone. If you're below 45,000 BTUs, so that's like your smaller apartment unit projects. Larger, I think maybe 4-ton, 5-ton units will be at 14.5 SEER. So these are split heat pump systems, ductless mini split systems, et cetera. Those are the minimums. So there's going to be a rush to buy these under SEER 14 this code cycle. So if they have them manufactured now, you can buy them next year. Otherwise, you have to purchase the new SEER rating equipment. The good news is that it's going to help your energy score in California and the rest of the nation. The bad news is that's going to add cost, of course, like everything else. So talk to your mechanical guy about that. So multifamily mechanical. So again, this is the California code. That last one was DOE. ERVs and HRVs, a new type of equipment is being called out now for next code cycle. And this is for fresh air and for heat exchanging that fresh air. So instead of bringing in, because right now the code is requiring you to bring in fresh air from the outside, well, or through a bath fan. Where's that air going to come from? It can come from outside. It can come from a neighboring unit. So what if it's 40 degrees outside and it's really cold and you're heating your space? And now you're turning on that bath fan and you're causing negative pressure. And basically you're pulling in cold air from the outside into your living unit and you're exhausting it. You're working against yourself from an energy and comfort perspective. So prescriptively, you don't have to do this. ERVs and HRVs will be handling that or addressing that comfort issue. And how these work is basically, we'll start with the ERV. These are placed in hotter, more humid climate zones where you have a lot of moisture in the air. And let's say it's a hot day outside and you're cooling your interior space. The hot air will come in through the fresh air outlet. And then that hot air is going to be transferred onto this heat exchanger. So the heat goes to the heat exchanger. And then the cold air coming in from inside the unit is going to pass over that heat exchanger, pulling or preconditioning that hot air, dropping the temperature down, and then condensing the water. So that way the water drains out. So you're not pulling in humid air. So the water drains out and cooler air comes back in because you mixed it with the cool air that you generated in your space. These are actually super effective, very efficient. They're used in passive house in Germany, the passive house rating system. They use these on all of those pretty much. And they have central heat exchange or energy recovery ventilators. They have central systems put in, let's say a passive house in New York, for example. So these are pretty effective. So this is an extra piece of equipment. Are we going to see these on projects? We're not quite sure. We're guessing initially the mechanical designers are going to say, don't put it in because it's going to add cost and we're going to have to add additional ducting, additional wiring. So we may run those models without these to see how things run and, and give some feedback to the teams and say, okay, yeah, you're going to need to put these in, or actually, no, you're good. You just increase your SEER ratings or whatever. But from the looks of it, some of these prescriptive values that we're giving you right now, or what the code is giving us, prescriptively, you're going to have to take some of these to pass code. So you can't skip on all of them and still think you're going to pass code. You're going to have to take something. And we just don't know what that is yet till the model is released. The HRV is used in colder, more temperate climate zones. So California, you'd use an HRV. So Florida, you'd use an ERV. And here's the requirements for dwelling units. So climate zones 4 through 10, when a heat pump space conditioning system is installed to meet the requirements, balanced ventilation system without an energy recovery ventilator or heat recovery ventilator shall have a fan efficacy of no less than 0.4. That's basically saying you're going to prescriptively put these in. When you do, they have to be efficiently running systems. They have to have enough air movement and they can't be consuming too much energy. And this is where a HERS test comes in. Okay. And then 4 stories or more, there's their own requirements as well. You can see them there. Okay. When these, okay, the question is, when do these prescriptive requirements start? They start January 1st, 2023 is when they start. So if you go into plan check after December 31st of this year, your first plan check, the new code is triggered. So you want to get your projects in before the code change. Common areas have to have fresh air, dedicated outside air systems, bringing in fresh air into those spaces, especially your gyms and your amenity spaces. If you have a LEED project, you have to bring in extra air into your amenity spaces. LEED requires a lot of fresh air for fitness areas. Domestic hot water for multifamily, so prescriptively required. A single 240 volt heat pump water heater within climate zones 1 through 16, you'll have a compact hot water distribution system. So that's basically short pipe runs, smaller pipes, get the, have a more efficient delivery system. So that way you don't have to bleed the water and wait for that hot water to come through the pipes. A drain water heat recovery system in zone 16, which is, that's up in the mountains, right? Zone 16. Drain water heat is when you're taking a shower and that hot water goes down the drain. You're taking the heat from the drain water out and putting that heat back into the system, back into the hot water tank. So again, this is prescriptive. For let's see here, yeah. For single family, heat pump water heaters shouldn't be too big of a deal. You can put in gas, but it has to be instantaneous water heater or a chain of gas instantaneous water heaters. And for multifamily, so a central system with multiple daisy chained gas water heaters. And we're going to get penalized a little bit in the energy model because we're using gas again, right? But they're still allowing you to use gas. And then for multifamily, basically what this slide is saying that, and I've talked to a few mechanical designers right now, they're saying they don't have a effective or readily available central hot water heat pump water heating system. We're probably going to keep using gas or go to some kind of central boiler system still. But initially, if we do have to switch over to a heat pump water heater, you're going to go individual tanks to pass code in certain cases, depending how the energy model flows. So if you don't do your heat recovery ventilators, if you don't do your rigid insulation on the roof deck, if you keep your SEER 15 down at the minimum levels, you may have to put in a heat pump water heater, right? If you elect not to do those other prescriptive requirements. And so we don't know how that's going to look like because we don't have access to a fully working model yet. We will hopefully soon. But you may be forced, if you have to use heat pump water heaters, you may be forced to putting them back in individually into every unit for an apartment building rather than having a central system. That's the feedback I've received from some plumbing engineers. Prescriptive central domestic hot water. So this is utilizing the sun to produce hot water, preheating the water. This is going to be prescriptive. And so basically, a lot of projects are not going to put this in. It's pretty costly. We're talking about $300,000 or more. Usually this is one thing that gets written off in most projects, but it could work. If you have a high-rise tower or a really energy intensive project, this could save you. This could actually be cheaper than putting in HRVs or ERVs or a central HRV ERV system in your building. So again, it's one of those trade-offs that we have to model in and see whether we're going to use it or not. Okay. And then lighting. This is the final slide here. So for lighting, this is under single family for this code cycle. They're moving it to multifamily next code cycle. They want you to specify 3,500 Kelvin lighting, so a warmer light. I think that's happening anyway. And then you're going to be controlling and dimming all of your lights. So any light that's adjustable or anything with a switch would have a dimmer now. So under cabinet lights, can lights, sconces, inside of a building other than common areas. So this is inside the residential unit. You'll be adjusting light levels with a toggle switch. And then for like walk-in closets, bathrooms, you're going to do a vacancy sensor or an occupancy sensor. You can use one of those two. A vacancy sensor, you have to manually engage it and then it turns off. So if you have windows in your bathroom, you're going to be able to manually engage and turn on the lights, and then they automatically turn off. So vacancy sensors are really good for kids in kids' bedrooms because kids turn on their lights and not turn them off. They leave, they'll shut down automatically. Aux sensors will turn on automatically and turn off automatically. Those are good for rooms with no windows. So a lot of times you need the light anyway. So auto on, auto off. So as you can see, there's a lot of pretty big ticket items here. We're talking about solar being added to multifamily. We're talking about HRVs, ERVs, cool roof requirements, insulation requirements in the attic, heat pump water heaters, all electric ready. So those are 6 big items there that projects are not really looking at right now. And so you've got this grab bag of measures, and then you select 1 or 2 of them. Do you pass code? Which are the 2 best ones to select, or the 3 best to select? And are we going to meet our energy budget by selecting, let's say, um, gas heating with an ERV with super efficient windows? Is that cheaper than adding in the central the individual tanked heat pump water heaters, right? So you want to model those in early, and you want to start in DD phase. Start as early as possible with this modeling, especially for new construction. You can do models for additions and alterations as well to try to get out of some of the requirements if you pass code. But start in DD, and once your sections and your elevations and your floor plans are done, now you can start plugging in systems and then get that feedback from your energy modeler, and they'll let you know where you stand and then coordinate with your MEP team from there. You want to have those design decisions done as early as possible, because I really don't think waiting until CD phase is going to be an option right now to run the model like we have been doing. We need that intelligence now before we get too far into design. I got a question here. This lighting requirement is disturbing. Some people suffer depression effects without access to bright lights. Yeah, yeah, that's a point. That's a good point. I don't think the code addresses that. Lights can be changed afterwards. A little harder with LEDs that are hardwired in. So yeah, I don't quite know how to answer that question, but I know it's tied to, they're trying to tie it to circadian rhythms, where because people are in front of blue light all the time in front of their computers or their cell phones. And so when your eyes don't know the difference between the light from your device compared to the light from the sun. And so at night, when you're supposed to be under warmer light, like that 3,500 Kelvin light, your body's supposed to drop its cortisol, drop its adrenaline, and then increase melatonin. That you automatically create that because you're getting ready for bed. But when we're always in front of those blue lights, that gives us a false trigger that it's daytime. And so those secretion levels of those uh, chemicals, for lack of a better term, are always higher. And so having deeper sleep or being more well rested is not happening. That's called circadian rhythm disorder. Which is interesting. Blue light blockers help. I'm wearing those. And there's other filters that you can utilize to help block all of that. But I'm sure there's probably a solution for people who are really sensitive to light like that. Natural light in sleeping areas should be a code requirement for 2023. This would impact the misguided windows dorm proposed for UC Santa Barbara. Yeah, I don't know what that issue is with Santa Barbara with the windowless dorms. Yeah, I don't know how you can go windowless. That's a prison. you know, um, but you could offset that through circadian adjusted lighting. And if you've heard of the WELL or Fitwell rating system, WELL has a credit there where the lights change colors during the day. So in the morning, it gets more of a blue light. It gets more towards a blue light, right? Like daylight. And then towards the evening hours, those lights start getting warmer. So it gives people that circadian rhythm effect if they're indoors all the time. Also a life safety issue. Great. Yeah. So you're welcome. Yeah, no, it's a health issue. It's a life safety issue. You know, depression is a big deal. And so people are affected by their indoor environments. And that's, I think, one thing architects should be aware of or are aware of or becoming more aware of, and how people's health is occupied or affected in these interior spaces. Always a good conversation to have with a prospective tenant or a client, sorry. Yeah, any other questions? Great, Siyama, you're welcome. Thank you for being here. You're welcome, Josh. I'll hang out for a couple of minutes, and if any questions pop up, I can get those answered. But if you want to copy the slide deck, just go ahead and email Marilee or myself, and then we can get you a copy. And yeah, I appreciate all of you attending and hanging in there. There's a lot of information to go over.
Mo, I emailed everybody your information, and I'll do the same for Kennedy.
Oh, great. Perfect. Thank you.
Thank you.
Yeah, lots of info. So lots for us to do next code cycle. So we'll all be busy, basically. And don't hesitate to reach out to Kennedy as well. They're on a lot of our projects, and they've had a lot of we've had a lot of good feedback from our clients with Cal Solar.
Yes, please reach out. We're happy to help with the part consulting process. So with Mo as well, early on in the process, all the way through construction. So even just fielding questions, we're happy to get on the phone or exchange via email.
Great. Well, thank you, everyone. Appreciate it. And until next time, have a good day. Bye, guys.
Thank you, Mo.
Thank you, Marilee.
Thanks, Kennedy.
Bye. Thank you.
Bye-bye.
Yeah, thanks, Mo. That was great. Thank you, Kenny.
Thank you so much.